Hello, my name is Mirella. I am from the School of Informatics at the University of Edinburgh, and today I will be talking about automatic movie analysis and summarization via turning point identification. And do not worry if you don't know what turning points are. By the end of the talk, you will all be very familiar with them. Okay, before going into the details of the talk, I want to introduce my collaborators. Penelope Papalampidi is a graduate student at the University of Edinburgh, and she has mostly contributed to the research you will be hearing about, the turning point identification. But aside from Penelope, there are three other people that have helped form the ideas in this talk: Leah Fairman, Philip Gorinsky, and Frank Keller. Leah and Philip are no longer at the University of Edinburgh, sadly, but still very valued collaborators. Okay, so let me start with a question/statement. Who doesn't like movies? Everybody loves movies. Some people love making them, others love watching them. And if you're Michael Dana here, you may think that we love films and storytelling as a people. And in fact, Michael Dana goes on further to tell us that it is just a human compulsion to listen to and tell stories. So according to him, the fact that we like watching movies is in our genes. And I forgot to say that Michael Dana is a Canadian composer, so he composes scores for movies. And here he's picking up his award and is telling us that movies are in our genes. Now, because movies are in our genes, movies are indeed everywhere. So here's a couple of statistics that I gathered for this talk with regards to the content shared at this point by Netflix and Amazon. And I mean, there's others as well, but let's look at those two. So Netflix has currently 67,000 movies, series, and shows. You can watch all of them if you have a Netflix subscription. Amazon is even worse. They have 24,000 movies and 2,100 shows to choose from. The average person watches 3.5 hours of television per day. So people watch a lot of television, and there is a lot of content that these providers want to share with us. Now, the problem is that there is too much content. So the average household has 3 streaming services. So you may have Disney Plus, Amazon, and Netflix, for example, or Apple TV and Disney Plus and Amazon, and any permutation of those you may like. Now, the polled users, this Likewise Inc. is a company, and they did a poll among American users, and they asked them, can you find something to watch, given that everybody has so many streaming services? And 70% of the users, of the viewers, agreed that they often struggle to figure out what to watch. And this is staggering. This is like a big number. And apparently, viewers need more than 15 minutes to decide what to watch. So, and you add that on top of your average Marvel movie, which is, I don't know, 3 hours. So this is a lot of time spent deciding what to watch, let alone then going and watching the movies. Okay, so we come in here and we want to help these viewers, and we want to make them happy. You see now this happy family that uses our technology to watch movies. So how can we help these poor users, these poor viewers? For example, viewers may want alternative trailers, or they may not want trailers. They may want a movie summary that summarizes an entire Marvel movie in 10 minutes. Another idea that another thing that viewers may want is not to have a summary, but to have some zoom in function that tells them what are the important shots in the movie. And this is highly personalized. Some viewers may want action-packed shots. Others may want scenes with female leads. Or if you like comedies, you may want to see all the funny shots or all the happy scenes. Okay, and so now we are moving from actually having content that is the same for everyone to highly personalized content. And we want to help these viewers, and you will see how we may be helping them throughout the talk. Okay, so Of course, there has been some previous work on analyzing the content of movies. And this is not surprising. Movies are cultural artifacts, but also are considered text, and they're also considered a form of literature. So there have been two types of approaches in the past. They only focus on text. That means they only process the screenplay. And for example, you can look at characters and create networks that tell you how the characters evolve through the movie. Or you may want to take the screenplay, which is like a book. Screenplays are very long. They're approximately 100, 150 pages. And you take the screenplay and you extract the scenes to create a summary. This is another idea. But of course, you cannot watch this. It's just a written summary. So this is one approach, one class of previous work, and the other approach focuses only on the video, and in particular, not entire movies. I don't know why. They just look at isolated video clips and they try to analyze them. And now we will depart from both of these approaches in that we will be looking at the multimodal space. So we will take a movie, and a movie for our purposes is the screenplay as well as the video. We will also try to process the entire movie. So we aim at creating a summary based on the full length of the movie. And the important point is that we will do that based on turning point identification. So to repeat, we will look at a movie from beginning to end. We will look at the audio, video, and text, the screenplay as well. And our goal is to be able to summarize this so that I take a 5-hour-long movie and I play you a 10-minute summary. How am I going to do this? We're going to do this by this idea of identifying turning points. Okay, so before I tell you about turning points and what they are and how we will use them in making summaries, let me just briefly summarize why this movie analysis and movie summarization, what we want to do to help users, is a very challenging task. Now, the videos, as you know, the movies are long. On average, they're 2 hours, and they are not only long. Most of the time, if you're watching a good movie, it's a complex story. So in order to summarize this, you really need to understand what's happening. What are the main events in the movie? The field has used some heuristics to be able to create summaries, in particular if you look at summarizing news documents, because in the news there is well-known conventions that, for example, the most important bits of information are going to appear on top of the news article. So if you extract these on top of the news article, you will create a more or less good enough summary. This is not the case with movies. Not all of the information appears in the beginning. It's interspersed throughout. So these position biases will not work. And also, if you try to identify importance heuristics or diversity heuristics, which people have done for other types of summarization, again, the task is so complex that all of these heuristics fail. So there is a problem of the understanding, and then there is a second problem, which is as important and as challenging, which is the fact that if you want to have a machine learning model to learn how to produce these summaries, this is a very challenging task because there is no annotated data available. So for news, one may find summaries. The people who write the news also sometimes write the summaries and they publish them, and we can get them and we can collect data to actually train a model. For movies, this is not the case. There are no labels available that will tell you this scene is important or it is not, or this shot is important or is not. Of course, you can go and create this, but this will be a huge effort and it will never be enough. So we have to be creative. We have to think of models that actually can handle this data paucity issue. So what can we do about these challenges? Our hypothesis here is that a movie summary consists of scenes that act as turning points. So if you look at the screenplay, a screenplay is naturally segmented into scenes. These are different locations or different things that happen in the movie, and we know them if we look at the screenplay. So our hypothesis is that different scenes act as different turning points. Now, of course, I haven't told you what turning points are. So let me begin by telling you that turning points are actually a very, very old idea. It goes back to Aristotle, who you see here in all his glory. Aristotle was very much preoccupied about how one tells stories. And he came up with this triangle telling us that every story consists of three main thematic units. This is the famous triangle. You start with the protasis. This is introductory material. Then things happen, more events accumulate. You have the epitasis, which is the climax, the most important events in the story. And then you sort of start having resolutions until you end up with a catastrophe, which is the end of the story. Now, this is what Aristotle said, and here we have Freytag a few centuries later, who takes this Aristotle triangle and turns it into a pyramid. And he says, well, the triangle is a bit naive. Here I have a pyramid, so there's more events happening, and I have the exposition, which is the beginning, then there's some inciting force, action rises, I have my climax, so he kept the climax, then falling action, some resolution, and the end. Now, Freytag is important because the modern theory of turning points is really based on this pyramid. So what are turning points? Finally, turning points are narrative moments. They determine the progression of the plot. So what happens from one point to the next? Without the turning points, there is no progression. And they segment the narrative into thematic units. And this is important. Once we have like this moment in time and there is a turning point, the plot will change. It will progress into another direction. And in this work, we adopt a modern scheme that has been put forward by Haig in a book written in 2017. And I should point out that these turning points are the bread and butter of screenwriters, in particular in Hollywood. And I forgot to say, whatever I'm talking about is how people do movies in Hollywood. Once I was giving another talk and I was asked about Bollywood, and I don't know, chances are though that most people have some turning points in their movies. So here's the modern version you see on the screen of what turning points look like, and these are the definitions that I will be using throughout this talk. So there is a setup. In the setup we have the introduction of characters, and then something happens, there is an opportunity, first turning point. The opportunity, because the turning points progress the plot, brings us into a new situation. While we're in the new situation, there is a change of plans. Plans have changed and there is some progress in that direction, at which point we reach the point of no return. So both the hero, the protagonist, and co-protagonists are committed to a goal. There will be complications and a major setback. And while I'm talking this, I want you to remember movies that you've seen and you liked. Most movies follow this narrative structure. After the major setback, there will be the final push. You either overcome the setback or not. There is a climax and the movie ends. Now, I know this is a bit abstract, so in the next slide, we're going to see an example. And as an example, we will use The Shining. The Shining is a psychological horror film that was released in 1980 and was produced and directed by Stanley Kubrick. And in fact, it is based on a book written by Stephen King. Now, when The Shining appeared in the theaters, opinion was divided. Some people liked it, some people didn't like it. Stephen King himself came and said, oh, it doesn't follow my book, I don't think it's great. Anyway, the point is The Shining has become a classic, and it is a beautiful illustration of turning points. Okay, so in the next couple of slides, I will show you exactly where the turning points are in the movie The Shining, and apologies if you have not seen it and you wanted to see it because it will contain some spoilers.
The only thing that can get a bit trying up here during the winter is the tremendous sense of isolation.
Well, that just happens to be exactly what I'm looking for. I'm outlining a new writing project, and 5 months of peace is just what I want.
Okay, so we've seen here, this is the first turning point, which is the opportunity. And it's an introductory event that occurs after the presentation of the setting and the background of the main characters. So we see here Jack Nicholson, he's the main character, and he is given an opportunity to go up in a hotel that is somewhere in the mountains to be the caretaker during the winter months where there is isolation. And he says that, you know, it's great. A little bit of isolation is fantastic because they have a writing project. He wants to write a book and this suits him fine. So after the opportunity, we have the change of plans.
Well, maybe things that happen leave other kind of traces behind. Not things that anyone can notice, but things that people who shine can see.
So here the change of plans is an important event. It defines the main goal of the story. And from this point on, the action begins to increase. And you see there is this dialogue, there is this child, this is Jack Nicholson's child, and the notion of the shining is explained. So the shining is some people have this shining and they can see, observe things that are unobservable to everybody else. And it turns out later on in the movie, we see that this child has this shining charisma. Okay, then we move on.
Well, I dreamed that I killed you and Danny.
So this is the point of no return. It's an event that pushes the main characters to fully commit to their goal. And here, Jack Nicholson tells his wife, I dreamed that I killed you and Danny. So this is his goal now. Remember, this is a horror movie, to kill his family.
Here's Johnny.
So now this is the major setback. So the main character, the protagonist, has committed to his goal, which is to kill the family. And from now on, he's trying to achieve this goal. And the setback is where everything falls apart. So he's trying to kill them, but of course they're resisting, and he has to overcome that. So this is the final turning point called the climax. It's the moment of resolution, if you like, and the biggest spoiler, here we see Jack Nicholson frozen. Maybe I can play this again. So he tries to kill his family, but they manage to resist, and in the end, we see him frozen in the snow. So he did not manage to do this. Okay. Now, let me explain how we will use these turning points to perform summarization. So like I mentioned before, we have the screenplay, we have the video, and we have the audio. We have like these three modalities which we will use to predict in the movie the turning points, much as you've seen that I've done already with The Shining. So we have to go in the movie and identify which scenes are representative of turning points. And like I said, there's 5 turning points. So we will identify 5 scenes. Algorithmically, we will have a model to do this. And then we will collate these scenes and create a video summary, which we can play to the users and make them happy. Okay, so we model movies as sparse graphs. Obviously, we have to have some way of representing these movies to be able to learn later on to predict the turning points. So we will adopt a graph theoretic interpretation of movies where nodes are scenes and the edges denote similarity between scenes. And we argue here that the graphs are actually quite important because they contextualize the scenes, and they reveal complex interactions between events. For example, movies are not linear, there is flashbacks and so on, and we assume here that the graphs will be able to represent that. And also because we take a movie and we turn it into a graph, we believe that it will be more interpretable, in particular if we sparsify the graph and we only sort of keep the important nodes. Okay, so I'll give you a sketch of the model without going into too much detail. So we have from the screenplay the scenes, and we can obtain representations for these scenes, and you can use whichever neural network model takes your fancy. It can be BERT, it can be BART, it can be T4, T5, anything you like. It can be an LSTM. So we have these representations of scenes, and starting from those, now we have to build our graph. And the way we do it is we take all the scenes that are the nodes in the graph and we compute their pairwise similarity. And how we do this is we measure similarity as a combination of textual similarity based on the screenplay, but also audiovisual similarity. So we want to take all the modalities into account. And so we create a complete graph where the edges have weights, and the weights denote the similarity between nodes, which in our case are scenes. Now, because screenplays have very many scenes, they can have, it depends, it varies from movie to movie. Some movies have only 50 scenes, others can have 100 or 150. So these graphs tend to be actually really big. So we sparsify them to highlight important nodes. And we do this by learning a sparse graph in an end-to-end model. And in particular, we learn what are the most important neighbors for a given node and select the top K ones. And this is the graph sparsification stage. So once we have sparsified the graph, then we take this representation and learn a graph convolutional network on top of this graph. In addition to this, we also take our scenes that are represented in any way you like, and we also learn their content by running a bidirectional LSTM. So we have the graph, and I have the bidirectional LSTM, and I have two types of representation, a more global representation, if you like, that is afforded by the graph, and a more content-based one afforded by the LSTM. I concatenate these two representations and I feed them to a classifier that will give me the probability of a scene being one of my 5 turning points. And I do this for every scene in my screenplay. So for every scene, in the end of the day, I will have the probability of it being turning point 1, 2, 3, 4, or 5, and then I will select the scenes with the highest probability and concatenate them together, and I will output my video summary. Okay, let me give you some more specifics before showing you some results. This model that I presented was trained on a dataset that we created. It's called Tripod. It contains 122 movies, approximately 18,000 scenes, and 1,600 turning points. So we actually had to go and annotate the turning points ourselves. People, when they write screenplays, they don't say, I'm going to have a turning point here and a turning point there and a turning point afterward. This is a way of writing the story, but they're nowhere indicated. And it turns out that people actually agree pretty much when they have to find these turning points. So we use this data set that we created because we have to be able to predict the turning points and actually see if we're correct or not. And we created graphs that we sparsified. So every movie was represented by a graph, and we kept up to 6 neighbors per node, per scene in a movie graph. And the way I'm gonna produce the summary is I will assume that every turning point is represented by 3 scenes, a sequence of 3 scenes. And if you do that, you have 5 turning points. So approximately you end up with a 10-minute summary. And it was the same compression rate for all the movies we looked at. Okay, one final word on evaluation, and then I will show you some results and what you can do with these graphs. So there's 3 ways of evaluating these output turning points, assuming you have some gold standard turning points that we had to create to be able to evaluate. One is total agreement, which is the percentage of turning point scenes that are correctly identified. Now, this is a very harsh metric. It turns out even humans don't have perfect total agreement. We have very many scenes and we have to identify one correct. So a sort of more representative metric is partial agreement, and this is the percentage of the turning points for which at least one gold standard scene is identified. So the algorithm will go and identify 5 scenes for turning point 1. If one of these is a gold standard scene, then this is good. We count it as a hit. And the third metric, which is also quite informative, is distance. So we measure the minimum distance in the number of scenes between predicted and gold scenes for a given turning point. And of course, we normalize by screenplay length. So partial agreement, higher is better. Distance, lower is better, which means that, you know, we predict a scene as a turning point and it's quite close to the gold standard scene. All right, so now let me tell you, let me give you some idea of the results. And the first set of results focuses on turning point identification, because if we can't identify turning points, there is no summary. So here I'm showing you the 2 metrics: partial agreement, higher is better; distance, lower is better, for 2 baselines. The first one is random, so we have the scenes and we randomly select scenes and we have hope for the best. We're hoping that we're going to hit a turning point. The second baseline, I call it position bias, but what it does is it takes into account some of the heuristics that people have in Hollywood when writing screenplays. In particular, there is this rule of thumb that, you know, the opportunity has to happen 20% in, major setback has to happen by half of the movie, and so on. And so we take these heuristics and we create this position bias, and you see that it's doing better in terms of partial agreement, but not so good in terms of distance. Then the next set of results are TextStrung and SynSum. These are both graph-based models, but do not have any notion of turning points or of events that take place in a movie. So TextStrung is a very well-known and supervised graph-based algorithm. It has been used to perform summarization in NLP, and it basically creates a graph. Nodes in the graph are scenes in our case, and it identifies in terms of outgoing and ingoing edges, the most important scenes, and this is our summary. SynSum is another graph-based algorithm that centers around the notion of a character. According to some other schools of thought in Hollywood, movies are nothing but characters. So here we identify characters in the movie. We build this graph of characters, and accordingly we identify the most important scenes. And again, you see that even though these algorithms have no notion of turning points, they do better than random and position bias. Now, TAM stands for Topic-Aware model, and this is a model that knows something about turning points. It again tries to identify them, but has no graph structure. So this is a sequential model that basically is sliding a window. You can think of it as a supervised text segmentation algorithm that slides a window along the screenplay and measures the similarity between different windows and decides whether to insert a boundary, i.e. a turning point. And finally, we have this graph turning point, which is the model I presented to you. And you can see that in terms of partial agreement, the graph TP model does best, and also it is does better than the topic-aware model in terms of distance, even though the difference here is less. Now, this is how we identify the turning points. What happens with regards to the summaries? Are they any good? So Here, I will present to you the results of a human evaluation where we actually played summaries created by these various algorithms to humans, so they watched them, and then we asked them, do the summaries contain the key events? And by key events, we explained to them what turning points are, and they have to say, does this summary contain turning point 1, turning point 2, 3, and so on. And we also asked them, are the summaries overall informative? Do you understand what's going on in this movie? And I only show you 3 models here. Simson, which is a graph-based model based on characters, no turning points. TAM is Topicaware model, which is based on, which has some notion of turning points, but no graph. GraphTP is the model I presented here, which knows something about graphs and turning points. And finally, GOLD. These are the gold standard summaries that we have. And we want, of course, to be approaching gold. And as you will see here, the graph-based, the GraphTP, which is the orange model, is doing pretty well. It manages to beat comparison systems for all turning points. And it is almost as close to gold with regards to the first turning point, the same for the second turning point. Turning point 3 is difficult. It's not so surprising. This is the change of plans. Turning point 4, it's doing quite well. Turning point 5, it's not doing so well. This is the major setback. This is difficult. And finally, it's the resolution. So overall, we see that the orange, dark orange is our model, is much better than the comparison systems, and in some instances even approaches the gold standard. So this is all quite encouraging, but this is not all it. We actually claim that the graph is not only useful to predict the turning points more accurately, but it's also important because it gives us insight as to the semantics of the movies and what makes them different. So the last part of the talk, I will show you examples of what these graphs mean. So we take these graphs that we create and we prune them to be able to inspect them. And we only keep turning points and their immediate neighbors. And then we measure the node connectivity. So how much a given node is connected to all other nodes of the sparse graph. And we also have grouped the movies into 4 broad genre categories to be able to do this analysis. And now I'm showing you the node connectivity per turning point for comedies and romance movies. And you will see that node connectivity is quite high, 0.8. This means that for these movies, comedies and romance movies and action movies, we start with with rather well-connected graphs. That means that you know, every character is connected to every other character, and all of them do things together, and the story is relatively coherent. Now, contrast this to what happens to thrillers, mysteries, and drama. So you see here that the graphs are less connected. So they have low connectivity, which indicates that the storylines are more complex. And also the graphs are more detached. Okay, so let's see some specific examples here. There are comedies and action movies, and there's 6 in this slide. And for example, The Wedding Date, I know nothing about this movie, but you see the graph is rather fully connected. The same for Die Hard, which is an action movie, Total Recall, and so on. So by looking at this graph, we can immediately say, okay, the stories are quite coherent, there's high degrees of connectivity here, and contrast this with dramas and thrillers. We immediately see that the graphs are more disconnected. Let's take Panic Room. There is almost like 4 different things that happen. The same with American Beauty. This movie has very much non-linear structure, and you see this is reflected in the disconnected graph. And in general, this makes sense for thrillers because not everything is revealed in the beginning. There may be new characters, and in general, the stories are more complex because, of course, there has to be something unexpected in the movie. Okay, so that's me. I thought rather than actually recapping what I've said so far, I will show you the turning points as identified by our algorithm for The Shining. But before I do that, let me just say three things. I've argued that movie summarization can be done by turning point identification. The movies are represented by multimodal sparse graphs, and these graphs, importantly, are interpretable, where the modal connections between events can reveal different properties and semantics of movies. Now, in the future, we want to concentrate on actually generating trailers based on shots, but this is very much future work. And without further ado, I will show you the turning points for The Shining as identified by our model. Thank you.
You do too, no. Now come on, tell me. You don't want to. Please. No.
You know, Doc, when something happens, it can leave a trace of itself behind. Say, like, if someone burns toast. Well, maybe things that happen leave other kind of traces behind. Not things that anyone can notice, but things that people who shine can see.
Mom, are you there? Red rum. 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 Stop it. Red rum. Red rum.
Wendy, I'm home.